Ah, hello everyone. That's my first time at the Xen Summit. I'm pretty new, and I will present and after discuss on something I'm working since September at the start, and also now with Vates, and at the start with Polytech Tours, which is an engineering school in Tours in France. So it's something related to IOMMU. So IOMMU Paravirtualization and some changes that I propose for the IOMMU subsystem for the PVMMU to exist. So let's start with the actual rationale. Why would we want to have this? So we would like to use SPDK with Xen, which relies on VFIO on Linux. So there are some presentations made in the past on the subject. So for instance, Damien presented that FOSDEM using SPDK with the Xen hypervisor for performance improvements with very interesting results. And a few years ago, there was a presentation, actually a design session on DPUs. So actually 2 years ago with Olivier and someone else. And we also want DMA protection for DOM0 because it has pretty much all of the devices. So we can't always trust the device to behave properly. So if the DOM0 has some weapons to protect itself from devices, it could be great. So all of this needs some IOMMU device and driver in DOM0. So that's the main ideas that of the PV-IOMMU interface, which is a proposed hypercall interface. So actually, this is not something completely new, but the interface is pretty much very different. So the idea is to provide some interface for creating what I call the IOMMU context, which are IOMMU domains in the IOMMU world. So it's exposed in a single hypercall with some sub-operations, like allocate and freeing a context. So we get the context number back at the return of the hypercall, and we can also specify some flags for the operations. So it's actually just for this part locating and freeing, but there's also more stuff we need, like actually modifying the IOMMU context. So mapping and unmapping pages. So for instance, the map page, we specify a memory frame from the guest view, which is much physical memory for the guest. The device frame page, which Linux calls it the IO virtual address. So this is a memory page that from the device point of view, which is translated to the guest frame number. The number of pages we want to map at once, because usually we want to map several pages at once, and doing the hypercall over and over for mapping a region is not really practical. And it also gives back the number of pages mapped for error checking mostly. And we have a similar operation for unmapping pages, where we specify the device frame number and it's getting removed from the IOMMU context. And we can also move devices from context from one to another. So this is pretty much a reattach device operation. So we specify a device that the guest has access to, and the guest provides the target context with the context number parameter, and it just moves the device from one context to another. So that's pretty much it. And something specific which about the context number is that the 0 context is the default one. So actually the there is no IOMMU for the guest. So what we actually use in Xen for the menu. So some of the issues of the IOMMU subsystem today is that the Xen IOMMU subsystem assumes that there is only one IOMMU domain per Xen domain. but it causes quite a lot of complications when we want to have separate IOMMU domains for other use cases like quarantine, where we want to have a specific context for our device, or PVMMU, where we can have multiple IOMMU contexts on a single domain. So, for instance, with x86, the IOMMU domain covers all the domain memory. So, like, there are some specific cases like PV mode or PVH with some flag. It creates another page table just for the IOMMU, and with PVH and HVM using the HAP mode, it reduces the page table that is used for the virtualization itself. So another problem that the current system have is that quarantine is implemented using device-specific attributes that refers to the page table. So it's quite a hack, I would say, and not really practical to work with in the IOMMU code. And we also have this page table to have some specific mappings, like mappings done to deal with some hardware issues. And something also important is that only x86 platforms have quarantine. So I haven't seen anything regarding ARM, and we probably want that as well on ARM. So, and on ARM, it's also another story because there is no PV or HVM. Everything is pretty much like HVM. And some functions appear to behave quite differently, like map and unmap operations that, as I understood, actually modifies the domain memory, which may not be what we would like to have. So it's actually looking like this. To put simply, we have, this is the VTD case. We have some address to a patch table, and this patch table is applied to the VTD hardware and applies to the devices. So what I would propose is that obviously we're not going to change everything, but some stuff may need to change. So we want to be able to manage IOMMU context individually, but keeping some compatibility with existing guests. Like by default, we should have actually no change to what we are doing actually. But when we want more context, we should be able to make new ones. So for that, there is a default IOMMU context which copies the current behavior, and we can make new ones. So due to the fact that there can be either the default context or not a default one, there are some functions that will be added, maybe modified because it will be more practical to work with, like something like hello context to create a single context, or reattach operations to change the context of the device, including between domains, so that can replace some functions. So that's it. So some ideas is to move some parts of the IOMMU driver code and behavior to platform independent code to make sure that we have some coherency between platforms, and also simplifies the work to work on IOMMU drivers and implement new platforms like RISC-V. So that's especially true for assign and deassign logic. That is quite tricky in some cases. So there are some side cases like MDVI has some stuff for interrupt mapping. VTD does things a bit differently. And also we're implementing quarantine on top of some platform independent subsystem, because the idea of quarantine is the same between platforms, but the implementation is platform specific for maybe no actual reasons. So using this new proposal, we can enhance the DOM.io, which is the domain for quarantine, and add devices, add context to it, and just have it's pretty much the same, but in the DOM.io instead of half in the DOM.io and in the device structure, not really practical. And well.
We already have
What do you can you
Yeah, but I mean, it's already there. I mean, there's already an option to create context device.
yes, but
They can share the same context.
My understanding of what is being said there is to rework this by using new concepts. So it's not like one per device, but reworking it so it's not ad hoc as it is currently, but rather utilize that there is going to be multiple context.
I think it's also worth pointing out. Yeah, I think it's off as well, isn't it?
You're pretty loud, Andrew.
Testing. That's better. Yeah, so it's worth pointing out that there is a specific thing called an IOMMU context in the VTD spec, but it's also being used as the generic. I want n ways of controlling it in the VM. So I think there's a bit of confusion over terminology.
so I decided to use the IOMMU context term because we already have in Xen code the DOM IOMMU code.
Yeah, so the important thing is at the moment in Xen, we speak VTD contexts properly because you have to the IOMMU. At the moment, an individual domain, including the DOM.io for quarantine, except in the magic case where it really is a hack, is that at the moment there is a single IOMMU context, which is both a single logical Xen's idea of some information about the IOMMU and a single actual real thing that a VTD calls an IOMMU context. And the purpose of this is to have more than one per domain and for it to be able to be controlled by the guest kernel.
Yes.
So, I guess, is this something that guest kernels are going to be able to, is the goal to provide, okay, so initially will this be just DOM0 that has it, or will other domains have it too? And also,
I'll go for one question first.
Ideally, I would say that. I already have one. Ideally, all guests should have access to it, or at least ones that we give the authorization to use this interface. But for now, only the domain 0 has access to it.
Yeah, so it's worth saying that at the moment it's DOM0 that needs it most. And DOM0 is also the easiest one to prototype what is both a new large hypercall set in the hypervisor and an IOMMU driver in DOM0. For HVM guests, it would be better to look into the nested IOMMU capability. So both Intel and AMD now have two-level translation on the IOMMUs, yes, where you can have Xen program the outer levels and give the entire inner level to the guest kernel, at which point we don't even have to write a driver for it because the guest kernel can use its native Intel and its native AMD driver. That's been available in AMD hardware for quite a while now. I think it's only new in Sapphire Rapids. They had it in the previous Skylake generation, but they got some of the control bits wrong and it basically didn't work under Vert. So for HVM guests, I think that's the way forward, which basically means this is a PV guest only thing.
Yes.
So what about PVH DOM0 then? Doesn't mean it's not needed at all in PVH DOM0?
It shouldn't be needed on PVH either, including DOM0, because it can as well run on a virtual IOMMU if we wanted to. Question to me here would be whether this could serve as an internal foundation to the IOMMU implementation, so we don't in the end up with two things, doing mostly the same thing, just once for PV and once for HVM.
Yeah, I guess the part of the thing is that it programs it differently.
It programs it differently, but it ends internally in the same machinery, internally to Xen.
Yeah, well, so for the nested IOMMU, we'd still only have one context for, because with nested IOMMU, we program the outer context in Xen, and we point the inner context at a guest register.
Yeah, the guest could itself use multiple contexts,
Yes, but that would be internal
and
to the guest.
that will be internal to the guest. But we need to reflect this internally. Right now, what we're doing is we put the same page table in every context entry if we use VTD terminology, and that would need to no longer be the case.
No, that's how you program it with nested. So with nested, Intel want you to reuse the EPT for it. So the way we currently program it for HVM guests would also be the same way we do it. We just also activate the second level translation, where you get one extra pointer pointing at a structure in guest memory that it wrote, that it then subdivides the source identifiers that it gets in. So the reality is that the way Xen currently operates, it is actually closer to the nested IOMMU page tables in actual real hardware. This is really only for Paravirt, I'd say.
Yeah, I agree. May I, because I wanted to go a step back and ask on the whereabouts of this proposal. There was, you're probably aware, an almost finished implementation of PVIOMMU like 5 years ago. And
Longer ago than that.
and the question, of course, from my perspective is, considering that it was largely finished in my understanding, there was a couple of revisions of patches that were posted and reviewed, and then it was abandoned, in how far the proposal is based on the findings there. If you actually looked at what was done in the past.
Actually, I was using it as a base, but a lot has changed since then. Like
Yeah, that there are changes is quite natural. The question just is whether some of the things that were worked out at the time would hopefully not need to be worked out again.
As it's going past, I'd say the work that we done was a little bit too minimal and has been bit rotting ever since then, so I'm happy someone else has done the hard work.
So having nested IOMMU in the hardware is great, but is it available in client parts? And if so, as of when? In other words, is this something Cubes is going to be able to use, or is this something that Cubes is not going to be able to use? Because you mentioned Sapphire Rapids, and that's a server part only.
Okay, fine, I meant Golden Cove. I think Alder Lake has it, but you may need some of the higher end stuff for it. Okay. In the case that you have nested IOMMU, we'd want to do it the native way. This could be used in the case that you don't have a nested IOMMU, whether you're PV or HVM. And certainly from an interface point of view, it should be agnostic of the two. Ideally.
Pass a page tables, like you said, Jürgen, I think. Then you probably want to pass a page tables if you are not entry, so build the page tables from DOM0 itself and just get a pointer to the root page table.
That would probably be less efficient. I mean, the batching that is going to be built into this proposal.
But I mean, then you would just do an hypercall with that pointer, and that would be it. If you have the second stage translation, you don't care about what the guest puts there.
If you're only referring to the top level page table, we'll have to reference count it like we do PV type refs. Otherwise, DOM0 could, an untrusted PV domain could write page tables that map arbitrary memory. And
No, because you are limited by the other table, basically. You are limited by the other.
I don't.
The second stage.
So you use this interface to program the inner layer when the
No, these.
Yeah, but we're talking about the case where we don't have an application.
Yeah,
Yeah,
So-
in the case that you have nested page tables, you're strictly speaking VTD or AMD VI. And we do that so we don't have to write yet another driver. This, I believe, has to come with a mirror driver in Linux that plumbs
Yes.
so it's a DMA driver in Linux that speaks these hypercalls and plugs it into VFIO.
Yes, there is on Linux an interface which is the IOMMU Ops interface.
Yes, that's the one I
And
meant.
I have a driver that speaks this interface with Xen and Linux, and
Yeah. So
Linux is pretty happy with this.
the point is this needs an extra driver in every OS we want to activate it on, and yes, we're willing to pay the price because it opens up a lot of opportunities that we have been neglecting, shall I say, for a very long time. But in the case that you do have proper two-level translation, working two-level translation in the IOMMU, it would be better still to activate it. One example is for AMD encrypted VMs. So in Xen 5 Turin, with the trusted I/O extensions coming, the guest kernel can program the inner half of the second stage translations entirely in encrypted memory. AMD have sufficiently separated it that they reckon that the outer hypervisor does not get to touch what the guest kernel can read and write, and they certainly think it's secure, and knowing who's doing it there, I will trust them to the first approximation.
Marek, do you think this is going to be something that? What do you think about a shadow? About instead of using PV and using shadow IOMMU page tables? I'm guessing that's because I'm just thinking I'm concerned that this feature might be skew locked away from hardware, or also the other question is, for a something client-based, can we afford to only support hardware that has this for certain things?
You don't need this.
Oh yeah, for this. I meant for hardware nested translations.
That's separate.
If you have two-level hardware available, you use it because it's faster. If you don't have it and you have this in Xen and you have the Linux driver for it, and that's probably all you care about, then fine, this will work for the same purpose.
Otherwise, you don't get
So
hardware.
if you have two-level translation, you won't go through that interface.
You need that for PB guests, probably.
Do you support them?
Yeah.
For HVM guests, you just use the native driver.
And
The native driver know how to
Yeah.
get this done. Okay.
yeah, and Demi, just one answer to shadow page tables. You have the problem that the item reading those page tables is not the CPU, so the performance penalty for page table miss of the IOMMU, I think, is absolutely catastrophic.
Well, no, the early IOMMUs, yes, it was terrible. The reality is the IOMMU is attached to the PCI root complex, and it's still the same number of hops away from the page table.
You need to interrupt the CPU, which is doing something to refill the page tables.
No, you don't. It maintains it.
Shadow page tables.
Oh, right. Yes, if they're proper shadow page, yeah.
You can eagerly refill. You could eagerly fill the shadow page tables instead of lazily filling them.
Yeah, but then you have to know which pages. You will have to do a complete page table to refill before each I/O, and that's expensive as well.
Yeah, but we're not pointing an IOMMU at shadow page tables. That just doesn't work. So the one key difference between IOMMU page tables and MMU page tables is that with IOMMU page tables, you cannot ever mark it non-present or mark it read-only, take a fault and do something as a side effect. You cannot do copy on write with IOMMU because the TLP timeout is measured in milliseconds and you can't send an interrupt in milliseconds. So, no, milliseconds.
You can handle an interrupt in milliseconds.
The IOMMU can't generate an interrupt and guarantee the core will service it completely in the timeout required for a PCI TLP to pass through the IOMMU.
That's a different issue.
As a result, you cannot do anything like copy on write. You can't do write faulting. So the IOMMU must be programmed to have real read and or write, if you permit it, access to the target memory. Obviously, if you're restricting it because it's not allowed to go there, then you take a hard fault and deal with it. But you can't do any kind of soft faults. You can't do copy on write. Something you passed over briefly before was the PT sync, PT share or not. You have an option. You can either share EPT and the IOMMU page tables, or you can have two separate sets of page tables that you maintain in sync. And the thing is, you can't even do log dirty in EPT, because if you mark it read-only transiently to catch writes on the CPU side, you break DMA into it. So the reason we have that option is to specifically prohibit sharing. And in that case, when, for example, we turn on log dirty to migrate a VM that has a device attached to it, the EPT tables go transiently read-only, and the IOMMU tables stay read-write. That is necessary in order to migrate a VM that has a PCI device attached. Now, at the moment, we do crazy hacks to get the dirty bitmap out of the GPU to do that. Intel have a spec called the SIOV spec, the Scalable IOVert spec, which is definitely not SRIOV, because they decided SRIOV was too bad. The SIOV spec has a device-agnostic way of getting read and write bitmaps like that. So you can merge dirty bitmaps quite easily. There's also a spec for getting a device-specific blob of state out of it. So the SIOV spec has everything you need to do migration in a way that doesn't require driver-specific hacks for everything. But you still have the limitations that the access must strictly always point to a real page of memory. You can't just interrupt the mapping and deal with it on demand. So there are still some restrictions there, even on the very modern hardware that claims to fix all of these bugs.
There is one exception, and that is there's one exception to that, and that is when the device itself is capable of recoverable faults, which some GPUs are. The GPU itself has a page table, and it can take a fault in its own page tables. That's not the IOMMU, though.
Yeah, the IOMMU either says yes or no, and it says no by providing a master abort, which is effectively an error status to the downstream device saying, nope, I didn't like what you did. And what the device does when it gets a master abort is up to it. Some of them just go and cry in the corner. Some of them try and continue onwards.
Just the devices that support page replacement. There is some sort of PCI technology to basically allow the devices to take page faults and then have those fixed up by the CPU.
So that's actually where SDPK is trying to go. So there's regular PCI, there's address translation built on top of that, there is shared virtual memory built on top of that, which is technology called sending a read or write with pass ID, where to start off, the device pre-negotiates a translation from a I/O virtual address, and specifically a GPU virtual address, into host physical memory passing through a guest CR3. So the way that works is you register in the IOMMU every CR3 of the processes that have a device attached to them. So the IOMMU can go and walk the CPU side page tables for them. And all of it depends on device side translation. So the IOMMU can still come back and say, no, I didn't like what you did, but it is required that the device pre-translates the virtual address that it wants to use and get a success back from that translation before it can actually start accessing user space memory.
You program the device with a virtual address.
Yes, it's so user space drivers can pass virtual addresses straight into the card.
It's It's like a second translation stage, basically. You first translate on that page tables, and then you translate on the IOMMU page tables.
Yep.
And doesn't that require ATS?
Yes.
Which means I'm guessing it's mostly a no-go for Xen.
Yeah.
Andrew's in the hot seat.
Yeah, well, ATS is not a no-go if somebody would take the time to implement it correctly. But right now, it is a no-go.
It's also worth saying that AMD have a beautiful fix for the security vulnerability that is ATS. So ATS is Address Translation Services. It was basically a whole bunch of high-speed networks and I think GPUs got really quite concerned with the performance slowdown when people turned on IOMMUs, so they went to the PCI SIG and specified this thing called Address Translation Services, where the device can ask for a translation of an address, and it gets it back. It has its own TLB on the device, and then the device can issue a DMA saying, trust me, I've already pre-translated it, just dump this into physical memory here, which, of course, is great for performance, and it violates every piece of security that the IOMMU was there to do in the first place. AMD have a solution for this. It genuinely works for the SEV Trust IO that's coming out in the next generation of hardware. It's called Secure ATS. When the device asks for a translation, it gets an identity map back. So when it then sends the next one along, saying, hey, here's the one that's pre-translated, it then just gets a regular walk at that point. It also means you don't need to pass invalidations back to the device. It's a really neat solution to the problem.
At that point, you may not enable ATS. So.
But you need to enable ATS to enable shared virtual memory, and people care about shared virtual memory. They don't care about the underlying features.
And also, some devices apparently just break if ATS is off.
That's the complicated one. There is a spec that says that is true. It isn't actually true, but what people wrote and what ended up in the spec are two different things, and that is a problem we need to resolve.
Can you just assume that the required ATS bit is bogus and ignore it?
That's one of the available options we are considering. Sorry, I think we interrupted.
Yes.
And let Teddy finish.
Starting the discussion that derailed this.
A lot of discussion. So, well, it looks like pretty much like this. Like we have the domain IOMMU structure. So that's why I took the term IOMMU context, because domain IOMMU domain is going to be quite confusing. So we have the default context, which is pretty much the base one, I would say, and other contexts of a limited number, which are separate patch tables that we can apply on the devices separately, instead of one patch table for all the devices, which is controlled by the reattach operation, either internally and with the PV-IOMMU interface. So it looks like pretty much like this. So to introduce this, there are some changes in the Xen IOMMU hub structure to allow a driver to provide these new operations. So, for instance, we have the context init and teardown operation to create and destroy a context, and some operations that are replaced with more general ones, like attach, detach, and reattach, that replaces assign, deassign, reassign, but using context instead of no parameter or another domain. So for instance, with reattach, we can either move a device from one context to another for the same domain, or or move a device from one domain to another in any context, so have more flexibility in this, which could be useful for quarantine in the future and also for PVMU. There are also some new common IOMMU functions. So one is for creating a context. So we have direct context access that you should probably not use instead of internally in the IOMMU subsystem, and some more general functions to actually that will be used, for instance, by PVMU code, or maybe another Xen part that will need it, like for creating a context, moving a device, adding a device to a context, and so on. So also have some draft for new quarantine logic with context. So basically, the idea is pretty simple. We create a context in the DOM.io, and we set up the quarantine and move the device in it. And that's it. So the idea is pretty simple, and if we have some idea on what are the mappings we want in the context, in the quarantine context, then it can work on all platforms that implement the platform-independent code. So that's a lot simpler than trying to implement quarantine in the IOMMU logic in some corner cases, stuff like that. So the status for this is that I have a PVMU driver implemented in Xen, so PVMU interface implemented in Xen, along with the compatible Linux driver that works without issues. I have the redesign proposal implemented for VTD, which still have improvements to do, but that's pretty good as far as I tested. The implementation works with either PV and PVH guests, and I was able to make DPDK and SPDK working without any issues with VFIO. There is a limits on IOMMU context, so the guest can try to start the hypervisor memory by creating infinite amount of mappings in the guest, in the context. So there is a fixed amount of memory, and if the guest goes too far, then the PVMU code is going to throw an error because IOMMU Subsystem fails to allocate some page or something like that. And it's going to be configured at boot and compile time with things like Arena or things like that. And also the idea is that reserved regions are mapped transparently during reattach. So when we move a device to some context, the reserved regions are mapped to this context if possible. If it is not, then the operation is going to fail. But there's some stuff to improve, like maybe the guest shouldn't be able to override this, like putting a mapping on top of the reserved region is probably not what we want.
So the reserved regions are effectively for platforms doing legacy terrible things. Examples of reserved regions are typically things like USB, legacy PC, legacy PS2 handling. A number of the Intel platforms with, what do they call it, AMT, basically had a device attached to the Ethernet card or the Wi-Fi card, scraping the frame buffer out of the integrated GPU, for example. We have also seen it on various HP systems where HP had some extra firmware in the network cards and the HBAs where it was basically doing stats reporting back into memory. So as far as the spec goes, the spec says that if an RMRR, which is the Intel name, AMD is IVMD region, I think.
Yeah, one form of the other.
Yeah. Basically says this device must have this range identity mapped. And like everything, it's a should, not a must. The reality is that nothing actually explodes if it's not identity mapped, But if, for example, you don't do that and then you give the USB controller to another domain, then legacy PS2 handling stops working, or you lose the ability to remote manage your system. So for all practical purposes, we really should honor the reserved regions. But
should you, for your legacy, I'm thinking for cubes, for cubes, it might be a good idea to deliberately not do that because we don't want legacy.
but you don't know why it's there, and if you configured the firmware not to have it, then it wouldn't have the RMRR, and then this would be a non-problem. If the RMRR is there, it is there because firmware thought there was a reason for it, and we can't just think we know better than firmware.
One question. You mentioned PVH here. Does it mean you have PVH with PCA pass-through?
It's PVH DOM 0, I think.
Yes,
Okay,
it's
it's
DOM
PV.
0 actually.
I think for cubes,
5
you
minutes.
might want to warn if there's an RMRR for the USB controller.
So the next slide is some open questions like the long question of how to upstream this, but I think it's a part of the next questions like what about MDVI and harm, because IOMMU is another story for implementing this.
What just happened?
Yeah, I mean, it's hard to say anything on such basic notes. Just start sending patches.
Yes.
You did send a couple of RC ones, if I remember correctly,
Yes.
and that's the right approach. We
Well.
just can take it from there.
But the rest of the questions are probably.
I think what you probably want to do is send an overall cover letter pointing to both a branch somewhere of your changes in Xen and the equivalent Linux kernel.
Okay.
I don't recall seeing that, but there are various people like Marek who will take both of them and just try it and play with it.
Yes, please.
It's also, for RFC patch series like that, it's useful to look at a high level and see whether it's an okay design or whether we may want to rethink things. You said you've cleaned up VTD, but you've still got AMDVI to go. Presumably that's not actually terribly hard because they're reasonably similar and they're not a massive amount of code. ARM, I have no idea about. I will defer to some ARM people on that. Certainly from our point of view, getting to MDev would be nice because more and more of the interesting GPU virt capabilities are depending on MDev.
Yes.
But certainly feel free to leave that to V2. VFIO on V1 is good enough.
So also some stuff to improve in.
One question on the last bullet point there. What is this specifically about?
It's when I map a page to CN. Okay. When I map a page to a context, then I had increment some reference counters so the page doesn't get freed, or at least. So when cleaning up
Would
the
sound like it's the natural thing you need to do, that you then need to clean up those ref counts.
So the idea is to clean up, walk through the context page table and decrease all the reference counters so page can be freed at the end if needed, stuff like that.
Yeah, I mean, the only remark there, be sure that you don't take too long to walk the page tables.
Yes.
We, in the past, we have found, I think, every variation on a guest being able to construct a simple operation that takes 4 minutes to complete, and the timeout is 5 seconds when you have the watchdog active. So, yeah, there are some tips and tricks for making that preemptible.
Yes, that's one idea that I had. So making sure that the guest can't make an hypercall that just takes a while install everything in the hypervisor. So
Yeah.
it's
Right.
like enforcing some.
I presume we have to actually stop now.
Uh,
Unfortunately,
proof.
says if you do want to have sessions, you can obviously stay. We do have a approximately 15-minute break, so you are welcome to continue if you want to, but
Okay.
be available upstairs as well.
Any more slides? Is it the last one? Or?
Yeah, there is another one with more questions. So, yeah. So some stuff regarding missing reserved regions that
Okay.
Roger told me.
We have a command line option for that. That should be good enough.
So there's a command line option for adding RMRLs that don't exist, a similar one for IVMD, and one of the other structures in AMD. In the Xen server patch queue, we've got a couple of patches that basically do a system quirk style thing, because frankly that is nicer than having the user manually write out an RMRL.
If you know it for a particular system, yes.
Yeah.
Shouldn't those be upstreamed?
I think we tried before, and I can't remember why it didn't work, but it was for the HP system that we found. But yes, I mean, the reality is we will always find bugs like that. We fix them when we find them. Don't worry too much about them,
Okay.
because the only thing you're doing is stressing yourself out when there's nothing you can do. The other thing to realize is that there are laptops and servers that have not been built yet that will cause bugs like that in the future. Yes, it's something to be worried about, but
Well, it's
we fix them when we find them, because that is
Okay.
the best we can do.
so also something regarding creating DOMUs with PVMMU. So there is a lot of plumbering with.
So we do now have an IOMMU, a general IOMMU set of flags in the domain create. Currently it's whether I want an IOMMU context. We can easily put a flag beside that saying, yeah, I'd like a PV IOMMU for this domain. One thing I did want to, I didn't stop you earlier, you said context 0 and allowing default access. That's fine for default compatibility, but there is a use case where we would not want to do that. One thing that is becoming increasingly important is pre-boot DMA protections, where things like the firmware will turn on the IOMMU before
Yes.
it enables memory decoding. So
Some
in our case, what we would probably want is another option to the domain create, saying effectively doing pre-boot DMA protection. Because in
Yes.
that case, so long as you know the software, and by this I mainly mean OVMF running inside the guest to set things up. So long as you know OVMF is capable of either having the Paravirt driver for this or speaking the Intel and AMD internal context, you want to block DMA until it has set up what it considers a safe set of contexts. And if at the time we're building all of this infrastructure, we can also put that in as an option. Because it's basically whether context 0 is default permit or default deny.
Yes.
That should be reasonably easy to fit in at this point. And
Or
it would,
maybe if the context 0 is actually just an empty context with no mappings at all, so
Yeah.
all DMA is blocked.
yeah, so it should be very easy to put in, and it will give us a great tick on the security box.
Nice.
One thing I wanted to add, because Andrew, you said we have that IOMMU flag in domain create. That's, as the slide correctly said, not going to be sufficient. We need to configure the pool limit. The limit on the pool that is usable for page tables.
Otherwise, you have easy DOS memory exhaustion.
That comes out of the paging mempool.
We could make it like this, but that's going to
Well, no,
be
it-
short in the paging mempool. I think we want a separate pool for that.
Okay, we can add a separate mempool, but it is currently bound by the mempool. Oh no, that's the one that isn't it?
Who uses MDev?
NVIDIA.
Gross. Sorry, I can't. Sorry, I shouldn't.
Yeah, but the point is we've got a full 32 bits, and I think we use 2 of them at the moment, so there's plenty more in there.
So also some stuff regarding VIMMUs. So harm people told me about some patches in the past about VSMMU, and there is also the MD-VIMMU part. So not sure how it integrates with.
So in Xen we have an implementation of a virtual IOMMU for AMD. Oh, did you actually delete it?
No, I didn't delete it all, but I started deleting it,
So-
and I think the rest should go as well.
So I accidentally had a bug where so it turned out to be dead code for a reason that was non-obvious. I accidentally fixed it to not be dead code, and it made some really weird behavior until we realized that it was totally broken and turned it back off. The internals of it are terrible. It seems all the maintainers are in agreement that you can just delete it, pretend it never existed, and maybe start again with something better. Yeah.
Okay. And also some idea of emulating the IOMMU with QEMU. And well, it's a complex topic because there's a lot of.
Yeah, leave that one for a while.
Yes.
It's rather more complicated.
It's a complex topic with Q35 and some other bricks needed.
It'll take long enough to get the rest sorted that you've
Yes.
put on the agenda.
Yes.
Yeah, get V1 working before you start planning V2.
And that's it.
Right, in which case we should probably have a break. Thank you very much.
Thanks you.